problems here. See, let me take a problem here. Find the value of k such that the following distribution represents the finite probability distribution. They are telling it is finite probability distribution. Finite means what? Discrete probability distribution, isn't it? Hence, find its mean and standard deviation. Here, for this problem, what and all we have to find? We have to find the mean, mu we have to find, and standard deviation we have to find. Standard deviation is sigma we have to find. And also you have to find p of x less than or equal to 1. This you have to find p of x greater than 1. And p of minus 1 is less than x is less than or equal to 2. These probabilities you have to find. Okay. See, in view of finding k under these type of problems, under discrete and continuous probability distributions, we have to consider, or we have to take the help of the definition of or the conditions of probability distributions, that is discrete and continuous probability distributions. Here, see, since it is telling about finite probability distribution, it is nothing but, see what they have given. They have given finite probability distribution. They have given, see the distribution what they have taken, x and p of x they have taken, right? X and p of x. X is minus 3, minus 2, minus 1, 0, 1, 2, 3. See, the distribution is given k, 2k, 3k, 4k, 3k, 2k and k. See, all these values assigned. See, finite probability distribution. Since it is given finite probability distribution, it is nothing but discrete probability distribution. Finite means discrete probability distribution, right? In discrete probability distribution, what is the condition? What is the condition for discrete probability distribution? I told you, na? For the discrete probability distribution, these are the two conditions has to follow. What is that? Each and every probability must be greater than or equal to 0, and sum of all the probability must be give you 1. So by using this condition, I can add these probabilities. So when I add these probabilities, and I have to equate it with what? I have to equate it with 1. Okay. So let me add these probabilities. So what I will get? Let me see. K plus 2k plus 3k plus 4k plus 3k plus 2k plus k. That must give you 1. Now I can find the value of k. Okay. Now when you add these things, you will get 16k, that is equal to 1. So k is equal to 1 by 16. So you can substitute this k value in this distribution, so that each and every probability will be greater than or equal to 0. Each and every value will be greater than or equal to 0, and sum of all these will give you 1. Of course, it is true. Now we found the value of, actually here we have to find the value of k also. Okay, we have to find the value of k also. Now the first question is done. Now we have to find mu. What is mu in discrete probability distribution? Mu is given by, for the discrete probability distribution, mu is given by summation I runs from 1 to n xi into p of xi, isn't it? See, these are the xi values, these are the xi values, these are the p of xi values. Okay, if you are not comfortable here, you can see here. Okay, xi values and p of xi values. I will take each and every value. See, I have to sum it. Xi, the first one, minus 3 into p of xi. P of xi means the corresponding value of x, that is p of xi, that is k. Okay, anyway, k value we know, that is 1 by 16. Yes, let me write first. It is asking the summing up, right? So that's why I'm taking plus minus 2 into 2k plus minus 1 into 3k plus 0 into anything will be 0, so I'm writing 0 here, plus 1 into 3k plus 2 into 2k plus 3 into k. Now let me simplify this. So when I simplify this, what I will get? Minus 3k cancel with plus 3k. 2 2s are 4, minus 4k plus 4k will get cancelled, and minus 3k will get cancelled. So I will get 0 here. I will get what? 0. Okay. So mu is equal to 0 I got. Mean is 0. Now let me find the next one. See, we found mean. Let me find the standard deviation. What is standard deviation? Standard deviation is given by square root of v. So we need to find v first. Later we can find the standard deviation. V is equal to summation I runs from 1 to n xi square into p of xi minus mu square. Okay. Now all the values which is there in the distribution, let me take it. Xi square. I have to square this value, and I have to multiply with the p of xi. Okay. Minus 3 the square into p of xi is k, plus minus 2 the square plus 2k. Sorry, minus 2 the square into 2k plus minus 1 the square into 3k plus 0 into anything is 0 plus 1 square into 3k plus 2 square into 2k plus 3 square into k minus minus mu square. What is mu? Mu is 0. So 0 square is again 0. Now let me simplify this. When I simplify this, I will get 5 by 2. If you want, you can simplify. I don't want to waste time here for the basic mathematics. Now, anyway, we got, what's the value of v? V is equal to 5 by 2. Now, standard deviation is given by square root of v. So square root of 5 divided by 2. This is the value of the standard deviation. See, we found the standard deviation also. Now, what we have to find? We have to find p of x less than or equal to 1. Now, p of x less than or equal to 1 we have to find. See what it means. See, it is asking us to find the probability of the values of x which is less than 1. I repeat once again, where they are asking us to find the probability of the values, probability of x which is less than or equal to 1. I repeat once again, it is very, very important to know. They are asking us to find the probability of the values of x which is less than or equal to 1. Okay, see, probability of x less than or equal to 1 means, see, it is 1 is here. You can find here 1, right? See, from 1, including this 1, less than or equal to means including this 1, less than means this side, right? So less than means this side means p of minus 3 plus p of minus 2. For all the probabilities we have to find p of minus 1 plus p of 0 plus p of 1. All these probabilities we have to find. Okay, now what is this? See, p of minus 3. What is p of minus 3? P of minus 3 is k, plus p of minus 2 is 2k, plus p of minus 1 is 3k, plus p of 0 is 4k, plus p of 1 is 3k. Now you know the value of k anyway. So 2k plus 3k 5k, 5 plus 1 is 6, plus 4 is 10, plus 3 is 13. So 13k, that is nothing but 13 into 1 by 16. 1 by 16 is the value of k. Okay, this is the value of the probability which is x less than or equal to 1. Now I have to find p of x greater than 1. P of x greater than 1. See, 1 is here. P of x greater than 1, I have to find p of x greater than 1. Greater than, see, 1 is here. 1, you can find 1 here, right? 1. Greater than 1 means this side. Greater than 1 means 2, 3. It is greater than 1. Greater than 1. And 1 is not included. It is not less, greater than or equal to. It is strictly greater than. Strictly greater than means what? It is 2 and 3. Not including. 1 is not included here. 1 is not included here. Strictly greater than 1. So 1 is not, since 1 is not included means 2 and 3. So p of x greater than 1 is equal to what? P of 2 plus p of 3. Okay. What is p of 2? P of 2 is 2k plus p of 3 is what? K. Now 2k plus k is 3k, and the value of k we know, that is 1 by 16. So it is 3 by 16. This is the value of p of x greater than 1. Now we found this also. Now let me find the probability of x lies between minus 1 to 2. What we have to find? P of x lies between minus 1 to 2. And here 2 included. Here 2 is included. In this distribution, x lies between minus 1 and 2. Minus 1 and 2. Minus 1 is not included because it is strictly less than. Minus 1 you should not take. So it is from here p of 0, okay, plus p of 1 plus 2 is there. Yes, since it is included, 2 is included, less than or equal to, 2 is included, p of 2. Now what is 1 is 3k plus p of 2 is 2k. It is 4 plus 3, 7 plus 2 is 9k. K value we know, that is 1 by 16, that is 9 by 16. This is the value of the probability of x which lies between minus 1 to 2. These are the kind of problems you can see under discrete probability distribution. Okay. Now we'll see one problem under continuous probability distribution so that we can understand well. Anyway, however, we have solved the problem under discrete probability distribution. In the same way, we are going to solve the problem in continuous probability distribution also. See, this is the problem I have. Find the value of c such that, here they have given the constant in terms of c. In the earlier problem, they have given the constant in terms of k. Here we have to find the constant c. Find the value of c such that f of x is defined like this. See, there the probability of p of x and x is distributed under the table. Here the f of x is defined like this, x by 6 plus c, where x lies between 0 to 3, 0 elsewhere. Is a probability density function. Find p of x lies between 1 to 2. See, for this problem, see, what is f of x is defined? F of x is defined to be x by 6 plus c, where x lies between 0 to 3, where x lies between 0 to 3, which is less than or equal to, okay, and 0 otherwise. 0 otherwise. This is the function defined, and here we have to find the value of c and the probability of x lies between 1 to 2. 1 to 2. Here they are not asking us to find the mean, variance and standard deviation and all. They did not ask anything about it. They asked only constant and the probability of this. Whatever they asked, let me find it. Okay. See, according to the condition for the continuous probability distribution, what is the condition? What is the condition? There are two conditions. The first condition is f of x must be greater than or equal to 0, and the second condition is integral from minus infinity to infinity f of x dx is equal to 1. See, these are the two conditions. According to this condition, the first condition says, what is the first condition? First condition, f of x must be greater than or equal to 0. Okay, x by 6 plus c is greater than or equal to 0, and 0 anyway it is equal to 0. Okay. The second condition says integral minus infinity to infinity f of x dx is equal to 1. Integral minus infinity to infinity f of x dx is equal to 1. Integral minus infinity to infinity is divided under the intervals. See, minus infinity to 0 f of x dx plus from 0 to 3, see, minus infinity to infinity. See, minus infinity to 0, 0 to 3, 0 to 3 is defined, and again 3 to infinity is not defined. Not defined means 0. See, here it is 0, here it is 0, here it is x by 6 plus c. This is a function defined, right? Now, see, from 0 to 3, f of x dx plus integral 3 to infinity f of x dx. Anyway, in the first and the third integral, the function itself is 0, so it is 0 only. Now for the middle interval 0 to 3 f of x, what is a function in the interval 0 to 3? In the interval 0 to 3, the function is x by 6 plus c into dx. That must give you 1, isn't it? That must give you 1. Okay, now let me integrate this. 1 by 6 into x integration is x square divided by 2 plus c integration is cx between the limits 0 to 3. That will give you 1. Now x is replaced with 3. Upper limit minus lower limit. How to apply limits? Upper limit minus lower limit. So that is 3 square divided by 6 to 12 minus 0 square divided by 12 plus c constant 3 into c constant upper limit is 3 minus 0. That will give you 1. Now it is 3 square is 9 by 12 minus 0 by anything is 0 plus c into 3 is equal to 1. Now 3s are 4s are, that is 3 by 4 plus 3c is equal to 1. 3c is equal to 1 minus 3 by 4. 3c is equal to 1 minus 3 by 4. That is 4 minus 3 is 1. That is 1 by 4. 3c is equal to 1 by 4. Now c is equal to 1 by 3 4s are 12. C value we got. This is how we have to find the constant in the continuous probability distribution. Okay. Now, see, in this problem, they asked us to find the constant value C that we found now. Now we have to find the probability of x lies between 1 to 2. Okay. Let me find it. What we have to find? We have to find the probability of x lies between 1 to 2, including 1 and 2. See, for this one, let me write the interval. See here, minus infinity to plus infinity, and from 0 to infinity it is defined to be 0. From 3 to infinity again it is defined to be 0. From 0 to 3 only the function is defined, and it is given x by 6 plus c, isn't it? Now they are asking us to find the probability of 1 to 2. See, somewhere here 1 and somewhere here 2. They are asking us to find the probability from 1 to 2. Okay, that is nothing but integral 1 to 2 f of x dx. That is nothing but integral 1 to 2. See, 1 to 2 we have to find. Integral 1 to 2 f of x. What is the function under 0 to 3? See, complete from 0 to 3 the function is x by 6 plus c only. So under 1 to 2 again the function will be x by 6 plus c only. So x by 6 plus c into dx. Now let me integrate here. So it is x square divided by 2 into 6 as it is plus cx between the limits 1 to 2. Now x square divided by 6 to 12 plus c into x between 1 to 2. Let me apply limit 1 by 12 into 2 square minus 1 square plus c into 2 minus 1. Substitute the value of c. So it is 1 by 12 into 2 square minus 1 plus 1 by 12. C value is 1 by 12, right? What is the value of c? C is equal to 1 by 12. So when you substitute the value of c here, 1 by 12 into 2 minus 1 is 1. It is 2 square is 4 minus 1 is 3. So take 1 by 12 common. So it is 3 plus 1. 3 plus 1 is 4. 3 plus 1 is what? 4. That is 1 by 3. So this is the probability of x less than or x lies between 1 to 2.